Okay, College Algebra 4.4, Properties of Logarithmic Functions. And this is 4.4a, the first video. And what we're going to start doing is look at ways that we can start solving equations with logs. So the first thing we're going to look at is something like 3 squared times 3 to the 4th power. Okay, so when you've done that before, the bases have to be the same when you multiply those, and you get 3 to the 2 plus 4. 3 to the 6th power. Okay, so when you multiply bases with exponents, you add the exponent, and the bases, remember, have to be the same. So the same is true when it comes to logarithms. When we have log base 3, and we have 9 times 27, so we have a multiplication there. What are we going to do? We're going to add. So we're going to write this as the log base 3 of 9 plus log base 3 of 27. Okay, so let's look at example 2. So we're not solving anything. There wasn't an equal sign there, just like there's not an equal sign in this one. We're just simplifying it, changing things around so that it makes it more useful to us. Alright, so what it's asking us there is it says express as a single logarithm. Now there's a key. If I'm going to express as a single logarithm, our bases have to be the same. Okay? And it says they're added. Well, what did we do? What do we do when we add? We multiply, just like on the last one. When we multiplied, we added. So we get a single logarithm that looks like that. Okay, so the next piece of logarithm properties we're going to look at has to do with when we have something like that. The power rule. That's 5 to the 6th power. We don't add those, we multiply them. Alright, the same works with logarithms. When we have something like log with a base a, and then we have a number here and it's to some power, that's going to equal p log a to the m. So basically this exponent goes in front of the log, and then that's how it simplifies it, because this is kind of complicated having a base and an exponent up here. If we move the exponent in front, we don't have to worry about it anymore. So let's look at example 3. We have log base a negative 3 power, and they're saying express each of the following as a product. So again, we're going to take the negative 3 and put it in front, and we get that. That's all they want. Alright, B is going to be a little bit trickier. We're going to use a base B. Or no, they still used an A. It's getting late. Alright, so we get that. Alright, so what I'm going to do is I'm going to change this. This is one of the reasons why you learned how to change the 4th root to a 1/4. So now I have a 1/4 there, and I can move it to the front. Like that. There we go. Alright, so you wonder, why in the world did I have to learn some of this? Well, when you get into this upper level math, you start realizing that some of it's useful. And you get that for C. Okay? Not much there. Alright, we're going to jump down to logarithms of quotients. I need another color here. Let's try orange. Alright, logarithms of quotients. So if we have 3 to the 4th power over 3 to the 2nd power, that's the same as 3 to the 4 minus 2, which equals 3 squared. Okay, that's what we're doing here with logarithms. So because of that, it gives us a formula that looks like this. a number divided by another number equals the log with the same base of the top number minus log same base the bottom number. Okay, so you subtract when it's dividing. And if they give it to you like this, like the second one, to make it into one logarithm, you divide. So you take your subtraction, divide, you change it to subtraction. And I'm sure they're going to give us some examples to practice this. And sure enough, example 4, express as a difference of logarithms. Log base t of 8 over w. It's going to be log base t of 8 minus log base t of w. Okay, example 5. Log, going the other way around now, b of 64 minus log b of 16, and that's going to give me log b of 64 over 16, which 64 over 16 is 4, so log b of 4 is what that would look like. Alright, so look, middle of page 392, it has some common errors. Okay, look and see what those common errors are. I'm not going to spend a lot of time on it, but you need to understand what is going on there as far as the errors go. Let's go to applying the properties for example 6. Get rid of this. Okay. Express each of the following in terms of sums and differences of logarithms. So we have log a, and then x squared y to the 5th over z to the 4th. And they want us to express that in sums and differences of logarithms. Alright, so we've got two different things going on here. We've got these two multiplied and then divided. So what we're going to do is we're going to do the division first. That's usually the case. So we have log a x squared y to the 5th minus log a z to the 4th. Okay? Now we're going to take this and split it up. You get log a x squared plus log a y to the 5th minus log a z to the 4th. Okay, so it's looking better. Now we're going to look at the exponents here, here, and here, and rewrite it with our final answer. Like that. And that's our final answer that they're asking for. Okay, let's look at B. Okay, what would you do first? I think I would make that into a power first. So I would do log a parentheses a squared b over c to the 5th to the 1/3 power. Okay, and then I'll take the 1/3 and put it here and take that away. In fact, I can just erase it. Alright, then I'm going to do my division next. Okay, then I'm going to split my logs up. In fact, I'm going to put I'm going to have to put these in parentheses because this 1/3 is times everything over here, so I'm going to have to make sure I keep it in parentheses. Alright, so I've got log a squared plus log ab minus log ac to the 5th. Okay, I'm getting down there. This one stays the same because there's no exponent on the b. And the 5 comes in front of there. Okay, and I'm still plugging along. Alright, if you remember, in one of your properties, you should have written down in your notes, when you have this, log a to the a like that, that's actually equal to 1. And then log a b minus 5 log ac. Sorry, I'm just writing way tons of stuff. Okay, so that ends up just being a 2, and then I distribute 2/3, so the 1/3 plus 1/3 log base a minus 10 or 5/3 base a of c. Okay, so that's what I end up with for my total answer for that. Now let's jump into C. Alright, C is a little hairy and I've got 3 minutes. So we're going to do the division first, and then we're going to split the A and the Y and the M and the N. So I'm just going to do all of that in one fell swoop. Okay, did it magic. Okay, so I split the A and the Y up in a plus because that's multiply. Put a minus there for the division, and split the m cubed and the n4 up. Next step is to take all of my exponents and put them in the front. Okay, notice what I did is I went from this step to this step, and in this step I took the parentheses off. Now when I took the parentheses off here, this became a negative. This negative has to distribute there, so this plus has to change to a negative, right? Because this is distributed to here, and then it's distributed there. So this here is very important to remember that that becomes a minus sign. Alright, I am going to stop there, and we'll continue on the next video with example 7.